Hello and welcome to Technically Edinburgh, the podcast for and about technicians at the University of Edinburgh. My name is Lee Murphy.
And I'm Charli Corcoran. And our guest for this episode is Joe Simpson. Joe is a mass spectrometry specialist based in the core mass spectrometry facility at the Queen's Medical Research Institute, University of Edinburgh. With a background in forensic science and a PhD in chemistry, Joe has built a career developing sensitive LC-MS methods to quantify small molecules in complex biological samples. Her work supports a wide range of research projects, from drug analysis to clinical studies, and she plays an active role in postgraduate teaching, supervision, and contributing to scientific publications. Hi, Joe. Welcome to the podcast. Thank you so much for joining us.
Hi, thanks for having me.
Can we start by you telling us a little bit about your role as a mass spectrometry specialist and what does that involve on a day-to-day basis?
Yeah, I think the title, probably most people wouldn't know what it is from the title. So day to day, I work in a facility within the university, and my day-to-day job can be different every day. So some of the typical things that I would be doing are receiving samples and logging them into our freezer systems, meeting with researchers to discuss projects and samples they want to analyze, extracting samples, and maintaining the equipment, and processing the data for the researchers.
And what kind of research do you do on a typical day? What kind of research do you support?
We support a lot of local researchers, so we're based within the Centre for Cardiovascular Sciences. So we support cardiovascular research. A lot of our research is based on steroid profiling. So Natalie Homer, who's the manager of the lab, that was what we started out doing initially. So many years developing pathways to analyze steroids, supporting endocrine research, so basically any diseases in the bodies that can disrupt those pathways. And we also support a lot of reproductive biology as well, so looking at sex steroids.
So what is mass spectrometry? Sorry, it's a very simple question there.
Yeah, if you imagine it, it's kind of a way of visualizing molecules, and the way we do it is we can measure their mass to charge. So we can accurately measure the mass of a molecule, and sometimes that's enough to identify it, but often in a sample there might be many things with the same mass. So the term liquid chromatography, mass spectrometry is the two parts of the analysis. So first of all, we want to separate everything out nicely, and then in simple terms, we send it to the mass spectrometer, and we're measuring the mass of those molecules.
What are some of the more unusual samples that you've worked with? Are you saying you're working with steroids at the moment?
Yeah, so predominantly we do lots of steroid analysis, but we can basically look at any small molecules the researchers are interested in. So it can be steroids, it could be drugs, it could be other pathways like bile acids. And we do get some unusual samples. So we had a project with a PhD student who wanted to look at measuring stress in whales. Mm-hmm. And during COVID, when the whale watching kind of stopped, that was a good opportunity for them to capture samples from these whales when they weren't being surrounded by tourists. So a very cool project. Basically take a petri dish and mount it to a drone and fly it over the whales. And what they were collecting was the whale blow, or the spray, mm-hmm. with the hope of being able to measure cortisol, which is the stress hormone. So that's a very different type of sample, and also very challenging because a lot of the sample is seawater.
Right.
And one thing that doesn't work very well with mass spectrometry is salt.
So how did you overcome that?
It's a case of kind of capturing as much sample as you can. You want to clean away all the things that you don't want, and then try and keep hold of those molecules of interest. So Tom was working on ways of trying to concentrate his samples down and get rid of the salts. And also that's a very difficult one because you don't know the volume of the sample.
Mm-hmm.
So if we have something like a plasma sample or a blood sample, we know how much we've taken, so it's easy to work out the concentration. But for a project like that, the volume's unknown, so there's different challenges there around trying to normalize the data that you get. But we do get some very odd kind of samples like that. Another one is a student that was measuring stress hormones again, but in archaeological bones.
Wow.
So she was trying to develop extraction protocols to get these molecules out of these very old bones.
And did that work? Could you get them out from that kind of period of time?
Yeah, so she was studying some samples from a monastery which came from some nuns, which they'd found evidence of osteoarthritis from the skeletal remains. But they wanted to look to see if there was any differences in the steroid hormones. They also wanted to look at vitamin D, which unfortunately they couldn't measure in the bones, but they were successful in extracting steroids from them. Again, that's just more of an unusual sample type. Yeah.
It's usually the unusual bits of work that kind of stick with us, isn't it? That kind of, that, or your kind of normal stuff, which is probably really interesting and exciting. Probably you're so used to it, you don't see it as exciting. It's always these little extra projects that you kind of focus on.
Yeah, something a bit different.
So, yeah, I mean, maybe thinking about that, how is it different working in a core facility rather than, a normal research group?
I think one of the main differences I've found from working in academic research groups is, particularly in our core facility, we're very focused around technology and how that technology can answer lots of different questions. Whereas in a research group, you tend to be focused on a biological question. So your expertise might be in a certain disease or, I don't know, cell line, whereas we're more about researching tools to answer lots of different questions, I think.
Yeah, I guess the magic is when you get both those together, isn't it? You kind of get that, that domain expertise with that technology expertise, and then coming together, I think, is really important.
Yeah, I think so as well. I think some students that come in to work with us are very involved, so the mass spec is a big part of their project. And we train them as what we call independent or expert users, and they'll come in and do the analysis themselves. But other students have such big, varied projects that the mass spec is a small part, so it's not worth them coming in and learning how to do it themselves. And they'll get better data if they just hand that part over to us.
So how did you get involved in mass spectrometry and end up working here? What's your career journey like?
I think probably not typical. So when I left school, I didn't leave school with many qualifications, and I kind of left after my GCSEs and I went straight into work. And then it wasn't until I was a bit older that I decided I wanted to go to university, and I did that through some access courses. So it's kind of like a crash course equivalent to an A-level. So one night a week you go and study this adult access class. And I did that for a year and went to university and studied forensic science. And the main reason why I went for forensic science is because I was struggling to choose between biology and chemistry. And the degree had both.
It does sound like a good mix of both, forensic science.
Yeah, and it's kind of just analytical chemistry, but with very interesting applications. I think it's an interesting way for students to learn. And then when I finished my degree, I went to work in industry. And it was really valuable to go and work there, and I learned a lot of lab skills, and you have to document everything very precisely. But after a while, I wanted to do something different. For me, I found industry is quite restrictive. So you have an SOP, you follow it, you can't change anything. It's very set in stone. And so I decided to apply for a PhD, and that was in bioarchaeology. So the application of mass spec to archaeological bone. And when I finished there, I went to use the same type of mass spectrometry, but looking at a different biological question. Again, kind of continuing the field of proteins. And once I'd finished that postdoc, the position came up in this facility, and it was a bit of a gap in my knowledge at the time because I hadn't done much small molecule analysis. I'd always been using mass spectrometry throughout my career, but more for proteins. And so it was an opportunity to kind of do something a bit different. But throughout my career, there's been a lot of different types of mass spectrometry and different types of questions, but that's been a constant for me. I think the technology.
I think you've maybe just answered the question I was going to ask, which why is your focus on mass spectrometry? We were just saying like it's been a constant through kind of your career. So have there been any challenges or key moments that you feel have really kind of shaped you and kind of directed your journey to mass spectrometry now?
I think when your key kind of skill is an application, whenever you start a new job, you feel a little bit like an imposter because it's a whole new question. So it's the same tool, but all of the background is new. And every time you start a new postdoc, the research is completely different. So you feel like you're starting again from scratch. And the part I enjoyed most about those projects was the application, so using the technology. So I think I was kind of naturally gravitating towards the facility side of things, but at the time it hadn't really crossed my mind. It just kind of came up by chance.
So in your role now in the core facility, you do a lot of supervising of postgrad students and kind of helping them and teaching them. What was it you enjoy about that part of the role?
Yeah, we got a lot of students and like a very wide range of experience. So we have sometimes school students come in, or undergrad students, master students, PhDs. And I think for me, when you have students that come in and they maybe aren't as confident, or they don't have a background in mass spec, and then over time you just see them kind of grow in confidence. And especially the PhD students, by the end of their 3 or 4 years, like they are the expert in their area. And I think that's very rewarding to see.
But you spend a lot of time kind of teaching, and helping them become these kind of experts. But then, of course, they get all this expertise, and then they go, don't they? They take that expertise with them.
Yeah.
Does that cause you problems? Is that an issue?
I think for the PhD students, they're with us long enough that it doesn't feel like a strain on us. But for the shorter term projects, I think sometimes you will be given students and people think that it's a helping hand. You could be given this extra pair of hands to come in, but it takes a lot of time and energy to teach students.
Yes.
So if they're only here for a short time, it's a lot of work for them then to leave, I guess.
Yes, yeah. Okay, and then you've also contributed to lots of research publications as well. Is that kind of usual for you to be a research technician on papers within mass spec?
I think it's like a very debated topic within the research community. If you're a postdoc in a lab, I think being named or contributing to research papers is just a normal thing.
Yeah.
I think within the research community, it wasn't always a guarantee if you contributed to a research project you would be named. It's changing a little bit now, but I think there's still, I don't know if it's the same for your facility, Lee, but there's still an expectation that because you're paying for a service, that you're not paying for the expertise of that person. Like, it's a transactional thing.
Yeah.
Whereas, in my opinion, if it was a postdoc doing the same research, they're also paid. They also have to pay to use the equipment. So I don't see what the difference is there. I think slowly technical contributions are becoming more recognized, but it's definitely not the norm. Like, I wouldn't expect to be named on a paper that I'd completed work for, if that makes sense.
But do you have a sense of which papers, when you're doing the work, you're kind of thinking, I probably should be an author on this one? Do you feel confident enough to kind of say, yeah, that I really think I should be an author now? Or do you kind of rely maybe on, somebody like Natalie, your line manager, to be doing that on your behalf? How do you cope with that?
Yeah, I wouldn't feel confident approaching researchers about that. I think there's a bit of a grey line and where your contribution counts. I think I'm very lucky in that Natalie advocates for us very well. If she believes that we should be named, she will have that discussion with the researcher. But it's not something that I would feel comfortable speaking to researchers about.
Okay, no, that's interesting. I think it is good having that kind of second opinion as well. That somebody else is kind of saying on your behalf, that we think you've come up to that kind of level and is fighting those battles. But yeah, I mean, having that opportunity, I think, is fine. But there are no clear rules, are there? And it's sometimes it can be a little bit of a grey area, as you say.
Do you feel that it's getting a bit better? It's getting a bit easier, to have that recognition?
I think so. I think as facilities, we're probably getting better at having these discussions at the beginning of the projects and laying out the expectations. But even though there are now guidances out there about fair publication and inclusion, it doesn't always work out well, I don't think.
Have you had a situation where potentially you and Natalie thought that you should be recognised, but as an author on a paper, but you haven't been?
I think there have definitely been situations where it's been suggested and not received well, and then it's been taken further. As far as I'm aware, there haven't been any outright no. And once it's pushed, normally that's accepted. But
okay.
I think if you weren't the kind of person to advocate for that, then it wouldn't happen.
Yeah, sometimes those conversations can be a little bit difficult, can't they, or uncomfortable. In my experience, most people have possibly just not thought about it enough. They kind of know their own research group, but maybe not kind of wider. But also, I think you're having a big effect because in your core facility, you do so much training. You've got this whole cohort of people who've known you and your expertise for so long, where it'll become natural for them to include you. So I think it does take time, but I can really see it changing.
Yeah, I think maybe as well an understanding from the researcher of what's involved in the project, because if you don't understand the technology and the processes, you might think like it's just pressing a button, or or you already have a similar method out there, so it's easy to add in this drug or this metabolite. And sometimes it is simple, but other times it's not, and it requires a lot of extra work to optimize and develop something new that they might not necessarily know.
So I was wondering, have you seen or felt the impact of the technician commitment much at all in your role in the core facility?
I feel like personally I haven't. I know that there's a lot going on and I can see the work that's happening. I think that these things maybe take time to gain momentum, and maybe in a few years' time we'll start to recognize the benefits.
What more do you think could be done then to support and develop technical staff in roles like yours?
I think two of the main issues that technical staff face are recognition for what they do, and also clear progression for them for their career-wise. So I think at the moment some technical staff don't want to be involved in I don't know how you would call it, like CPD, because those things are not recognized for them on an annual basis when they have the review. So unlike an academic staff member where they will be regraded based on their performance and these extra things that they've done, the technical community are graded on the role. So I think that's a barrier for them because they think there's no point to develop or do these extra things because they're not recognized. I'm only being judged on what my job description says.
Yeah, that's very clear from HR, isn't it? It's it's the job that's graded, not the person.
Yeah.
And that is a structural thing within many universities. Not every university. Some universities do have these promotional pathways now. Warwick, Liverpool, really good examples out there, but we don't have it. And we can do as much as we can. There's technicians ground up, and this kind of technician commitment is a ground up thing. But until you get those big changes from the top coming down that allow you to change that structure and allow these promotional pathways, that's not going to change, is it? And you see this frustration all the time.
Yeah, and I think it means that you end up losing expertise as well in a way, because if people feel like they don't have anywhere to progress, they're going to take offers in other places with better opportunities, and then you lose a lot of knowledge and skills, I think.
I think visibility, that's slightly different. I think maybe I would disagree with you a little bit there. That I think there is a lot we can do ground up for visibility, but again, I take what you say, that if it's not recognised in any kind of promotional pathway, it is difficult to get people involved. We don't see huge numbers taking up these kind of opportunities we're trying to provide through the technician commitment. Yeah, it is a bit of a chicken and egg, isn't it?
Yeah, I think that people lose maybe motivation, and then it's like the circular thing, like self-fulfilling thing. And I think it also depends on your management as well. So some people are lucky that they have very supportive managers who will encourage them to attend these opportunities, but I don't think that's universal across the university.
No, and I think it really depends on what roles people are in. Like if everyone in your department took an hour off to go to some CPD or some event, then that's your facility shut down for an hour. You can't do any work, so you're losing money, you're losing research. So it's difficult depending on what role you're in, even if you have a supportive manager to kind of support those things.
Yeah, exactly. If everyone's attending a conference or something, then you have to accept that nothing's happening that few days. Yeah.
Well, that's a bit of a downer. We kind of finish on an up. So I know you, Joe, and I know you like your job and you love your mass spec machines, and so if people did want to follow you into that kind of core facility and mass spec kind of role, what kind of advice would you have for people? What should they be thinking about?
I think that in my experience, the PhD has really helped me kind of make that smooth transition, but I don't think that you need a PhD to get into this role. And I think that you could enter this pathway with not even having a degree. I would say that if you're interested in core facilities, to look at the technologies that you're interested in and directly contact the people working there, because there are lots of opportunities, and I think that you can learn the job and gain the skills at any level. especially I think we don't have a lot of younger people coming in, which we need, because the older people will retire and we need to kind of pass on that knowledge. So yeah, I would recommend anyone that's interested in facilities or specific technologies to try and get in touch with people.
And what about mass spec? Where's the future of mass spec? Where's this technology heading?
I think sometimes people might not appreciate that mass spec has all these different specialities that are very different from each other. So you have proteomics, metabolomics, quantitative, and people might think if you into mass spec you just know all of these things, but all the different fields are kind of going off in different directions, and I think it depends which kind of area you're in. For us, we do a lot of targeted small molecules, so we're about absolute quantitation. So opposed to an omics experiment where you want to just try and capture as much information as you can from your sample, you might not necessarily know how much of everything in there. We're really focused on quantitation, and we have reference standards for everything that we want to measure. And I think maybe the future in terms of our technology is that people want to get more for their money, more information. So maybe branching into more of an untargeted approach, or being able to do multiple sets of analysis on one extract, those kind of things. Yeah.
More bang for your buck.
Yeah.
Great. Brilliant. So thank you so much, Joe. It's been really interesting learning about your role and your career and the things you get up to. And I really like the whale project. So I'm going to go away and see if I can find more about that.
Yeah, if you have a look, there's a website called WhaleWise.
Okay.
And that's the organisation that Tom, the student, was working for, so you can learn.
Oh, we could put a link in the...
Yeah, so did you say WhaleWise?
WhaleWise.
Amazing.
And didn't you do like tigers and pandas as well, and reproductive?
Yeah, we have a lot of strange samples from the zoo. Yeah, there was a big thing around pandas and trying to get the pandas to breed at the zoo because they only ovulate once a year, so their window for reproduction is small.
Very small. Yeah.
So there was a lot of research going into pandas, and Natalie's always talking to people, and we have a lot of collaborators that send us funny things like mosquitoes or I don't know, anything you can think of that you could measure steroids in.
So it's not just samples and research groups from Edinburgh Uni, it's kind of wider than that.
Yeah, we have samples coming from all over, and I think having those collaborative projects outside of the university kind of helps us to be more sustainable in supporting the local researchers, because they're contracts that are coming in from outside. You can charge more, and then kind of subsidizes the research for the local researchers.
That's great. Very well. Thank you so much. It was really nice to talk to you. Thank you for your time.
Cheers, Joe.
Okay.
Bye.
Bye.
Bye. Once again, thank you so much for listening to this month's episode, and we will see you soon. Recognition and visibility are two of the key areas of the Technician Commitment, an initiative led by the UK Institute for Technical Skills and Strategy. It's so important to us that we make sure that technicians behind the research get the recognition and visibility that they deserve, and we hope this podcast is one small step towards that goal. Technically Edinburgh is hosted and edited and produced by members of the University of Edinburgh Technician Steering Committee. Please follow us and subscribe wherever you get your podcasts, and don't forget to tell your friends and colleagues. Have us on obnoxiously loud in your lab so everyone can hear. Oh, and if you have any ideas for topics, would like to come along and chat with us, or even think you might like to have a go at hosting, please get in touch at technician.network@ed.ac.uk. Thanks again to our amazing guest, our brilliant co-hosts, and you for listening. See you next time.